y equals x squared plus 2 over x. Well, this function is another cubic hiding. If I multiply this term by x to add the fraction, I'll get x cubed plus 2 over x. It's a cubic over a linear. What do you think the asymptote is going to look like at the extremities for this graph? Let's use our usual method. Intercepts. For the y-intercept, put in x equals 0. I can't. It's undefined. So I'm going to end up having a vertical asymptote at x equals 0. I'll leave that till I get to discontinuous. For the x-intercepts, set y equal to 0. Well, that's going to be, I'm going to use this version, x cubed plus 2 over x. Well, I'm only interested in the top, x cubed plus 2, x cubed is negative 2, and x is the cubed root of negative 2. Now, just like the last example, I'll give you an approximate value there. It's approximately negative 1.26. But you don't need this. All we need to do is label the point where it crosses as the cube root of negative 2. Or if you prefer, the negative of the cube root of 2. Okay, discontinuities. The graph is discontinuous when the bottom is 0. That's a vertical asymptote. Extremities. As x approaches plus or minus infinity, what is y doing? Well, this term is going to become 0, and y is going to become basically x squared. Y approaches x squared. This is a parabola, a parabolic asymptote. Up until now, you've probably only seen linear asymptotes, but this one is parabolic. Will my graph cross this asymptote? No, it will not, because this will never be 0. It'll get close, but never will be. But it will be on either side. Let me show you a way to write that so you can keep track of what's going on. Graph will not cross the asymptotes. As x approaches negative infinity, what's y doing? Well, this will always be positive, but this will be negative. So it'll be just below x squared from below. Now, last time I wrote one like this, I put a minus after to say from below, but it might be a bit confusing what the minus was referring to, so I've actually written from below. Next point of interest is my vertical asymptote at x equals 0. As x approaches 0 from below, what's y doing? Approaching from below, this is always positive, this is going to be negative. So I'm going towards negative infinity. As x approaches 0 from above, this is positive, and this is now going to be positive. So I'm approaching from the right up to positive infinity. And as x approaches positive infinity, y is going to approach x squared. From which direction? Well, this is now going to be positive, so it's x squared plus a little bit. It's going to be from above. Let's draw a quick sketch. I've decided to draw my asymptotes with my purple pen because my green pen is just too faint now. Hopefully you can see that one. Okay, on the video, x equals 0. My other asymptote is a parabola. Y equals x squared. That's an asymptote to my graph. What's my graph actually doing? Well, at negative infinity, it approaches from below. It's here. At 0 from below, from the left, it's down here. And that makes sense because it crosses the x-axis at the cubed root of -2. So it's going to come down here and go across down to there. And this point of intersection here is the cubed root of -2, 0. And that's again why you didn't need that exact position in decimal, because for the sketch it's perfectly fine. On the other side of this line, it approaches positive infinity. It's not allowed to cross this asymptote, so it must approach that other asymptote from above. And there's going to be a turning point in there somewhere. I wonder what the coordinates of that turning point are. Shall we find out? Y equals x squared plus 2 on x. Let me rewrite that differently. X squared plus 2x to the -1. So y dashed is 2x minus 2x to the -2, which is 2x minus 2 over x squared. Well, that's 0 if and only if these two things are equal. 2x equals 2 on x squared. Cross multiply. X cubed is 2 over 2. X cubed is 1, which means x must be 1. Well, if x is 1, then y must be 1 plus 2 over 1, which is 1 plus 2 is 3. And I can put that point in 1, 3 as my stationary point. This point here is 1, 3.